Hello and welcome to today's lesson, where we shall be looking at the integral of cos cube theta d theta. Now the method we are going to use in this problem works for every odd power of cos theta. So if here is 3, 5, 7 and so on and so forth for all odd powers of sin theta, the method is as follows. Now since the function is a function of cos theta, you say let u be equal to what? Sin theta. And that's the method. This is a trick to it. That is to say that if this function was a function of, say, sin cube theta, we would have said let u be what? Cos theta. So the integral of cos cube theta d theta, the first step is we said let u be equal to sin theta. We now differentiate u with respect to x. So du over d theta rather is equal to what? Cos theta. We now make d theta here the subject of this equation. So that gives us what? So this means that du is equal to cos theta d theta. So that if we make d theta the subject, we have that d theta is equal to du over what? Over cos theta. So we go back to our original integral of cos cube theta d theta. And where we find d theta, we replace d theta with what? Du cos theta. As follows. So this implies that our integral cos cube theta d theta now becomes the integral of cos cube theta. Now the theta now becomes du over cos theta. If we simplify this, this becomes the integral of cos squared theta du. Since cos theta will cancel one of the cos theta here, we have integral of what? Cos squared theta what? D theta. Cos squared theta du, not d theta. However, we should recall that sin squared theta plus cos squared theta is equal to what? Equal to 1. So if we make cos squared theta the subject of this equation, we have cos squared theta is equal to 1 minus sin squared what? Theta. So in place of cos squared theta here, we shall be replacing with 1 minus what? Sin squared theta to get the following. So it implies that the integral of cos cube theta d theta now becomes the integral of cos squared theta. Now this becomes 1 minus sin squared theta d theta. Sin squared theta du remains here. However, we had said here that let u be what? Sin theta. So if u is sin theta, they will expect that sin squared theta should be what? U squared. Since sin theta is u. So sin squared theta should be u squared. So this implies that we have the integral of 1 minus u squared du. So now we have our integral in terms of du, and the variable in question now is also that of u. We can integrate. So if we open up the bracket, we have two terms. We have integral of 1 du minus the integral of u squared what? Du. If we integrate, we have the integral of 1 du is simply u minus the integral of u squared is u cubed over 3 plus c, the constant of integration. But what is u? Our u is nothing but what? Sin theta. So this follows that we have sin theta minus sin cubed theta over 3 plus c. Therefore, we have just integrated the function. We have shown now that the integral of cos cube theta d theta is equal to sin theta minus sin cube theta over 3 plus c, our constant of integration. So you should be informed here that the method we have used here is this method of saying let u be what? Sin theta. However, there are other methods of solving this integral. One of them is that of using trig identities. And however, if you use that method, you arrive at a solution that is different from this, but are equivalent. Yes, are equivalent. So I suggest that you subscribe to this channel if you have not already done so, so as you get all our future updates directly. Bye.